All right, let's go ahead and start our next chapter here. We're starting to wind down on the school year and on the semester. This is going to be a process called hypothesis testing. A lot of the thinking and identification is very similar to confidence intervals in that you're looking up for, are standard deviations known, are they not known, or are we going for population proportions or population means? The biggest thing we're doing is testing one individual claim. So hopefully by the end of this video, you'll be able to look at all this and generally have an idea what I'm going for. This video will not cover this one or this one. We'll save that one for a little bit later, but we're going to try to get the basics and the Z and T test down. So let's start looking at it. All right. First, this was a flow chart I made a long time ago. And we'll talk about all these different pieces. But if you go through this flow chart and travel your way down, you'll notice it's the same thought process you had when trying to choose confidence interval, appropriate calculations for confidence intervals. We will end up using these conclusions quite regularly in our hypothesis testing. So if you need to refer back to this, please do so. One final thing, when we get to this box right here, and this is all we're going to mess with today, right? Normally to say, is the population standard deviation known? If yes, then go to Z test. If no, then go to T test. Well, in tests, we have one further qualification. We can basically ignore whether it's a population standard deviation and go straight to Z test if the sample size is over 30. If the sample size is over 30, then the sample standard deviation really starts to approximate the population standard deviation. If it's less than 30, though, we have to use a T test. We're going to rely on our calculator a bunch to make some of these calculations, but let's look at what some of the moving parts are to this thing. So we're going to take a sample taken from a population with an unknown mean and a standard deviation, and there's going to be a claim in our problem about the true population mean. Then we're going to do a hypothesis test to be able to accept and say, yes, this population claim is probably true, or we're going to reject and say, no, try again. Our sample does not support your hypothesis. So broke it down very step by step just so you can see some different pieces. But suppose that an automobile manufacturer advertises that a new hybrid car has a mean gas mileage of 50 miles per hour or 50 miles per gallon. You take a simple random sample of n equals 30 hybrid vehicles and test their gas mileage. You find that in this sample, the average is X bar 47 miles per gallon with a standard deviation. Does this indicate the advertisement statement is true or false? So mathematically, we're trying to call bull crap or no bull crap. We're saying maybe, maybe not. All right. The first thing to notice on this line is because the sample size is greater than or equal to 30, it doesn't matter that this is a sample standard deviation. Because it's greater than or equal to 30, we are going to end up doing a Z test. All right. The first thing you need to do, and I'll end up putting all this back together so you can see a full answer. This is rewrite the claim about the population mathematically. So advertises this claim. Our null hypothesis, as it's called, and we'd write H sub 0 stands for null in our stats mathematical world, is that the population mean is 50 miles per gallon. All right. It's very important that you use the population mu here, as it were, because that's what we're trying to test upon. We already know what our sample standard deviation is, so we don't want to use X bar. Okay, you take a simple, does this indicate it? So if we read all this, all we want to know whether this is true. We're not trying to figure out whether it's higher or lower. All we're trying to figure out is whether it's true. So we write H sub A as in the alternative hypothesis, right? And what we're trying to say is this is not equal to 50. It's kind of the difference as in a court case. If you would ever go to court, please don't. But we'd say the null hypothesis is that you are innocent until proven guilty. And then the alternate hypothesis would be that you're not innocent. All right. We just need to find some kind of case to be able to reject the null hypothesis if we want to prove somebody not guilty or guilty. Okay, determine the probability threshold for making a decision to reject the null hypothesis when it is true. This is called the level of significance. So the level of significance is our baseline of we're saying, all right, the probability of pulling a certain sample must be at least above this probability. This is where we are going to draw the line in what we believe, all right? For this case, there was no level of significance given in this problem. So what we're going to do is we're going to default to this. So what we would write is this little fishy looking thing, right? And say that's equal to 0.05. That's what we're going to end up comparing to what's known as a p-value, otherwise known as the probability, all right? Okay, this says calculate, but we actually already know these. So really what we would just be doing is recording what we know. And then it says calculate the p-value. Because we've already determined that we're going for a z-test, all right, you can go into your calculator. You can go to the stat button, over to tests, and then because we've chosen z-test, you'll go to z-test, and there will be stuff to put in there on your calculator, right? So we're going to make sure that we're on the stats portion because we don't have a list built out, and we would start putting in some of this information. So mu sub 0 is the same as what you record as your null hypothesis. So we're saying 50, right? The standard deviation is going to be 5.5 when you're putting that on your calculator. X bar is 47. The n is 30. And then the symbol that we're choosing is this, because we're in. Another thing I should bring up, this is what's known as a two-sided test. We'll refer to one-sided tests as those problems arise. All right, so let me put this in. 50, 5.5, 47, 30, not equal to, calculate. All right, and somewhere on your calculator, it spits out this p-value. And you wouldn't have to write out all those decimal places. I'd probably just go 4 out. So really, we could just stop right there. But the way to interpret this is, if this claim were true, if that were true, then the probability of pulling this sample, this average with this sample size, is less than 1%. All right. The probability of pulling a sample of 30 and having their average be 47 miles when the true population is supposed to be 50 is less than 1%. It's less than half of 1%. So going down here to step 6, 0.0028 is less than the 0.05 threshold that we'd set with the level of significance, is basically where we're calling bull crap. We're saying mathematically the probability of pulling this sample right here with this average is so low that we don't believe it, that something mathematically is off. And what's off is this original claim, because we know we took this and recorded this true. So what must be off is our original claim, causing this probability to be so low. We'd probably expect this average to be higher if this were true. Let me turn a slide and show you what a full problem of this looks like. Okay, so we collected all these things throughout the way. What I'm going to do is do a full problem, collecting a lot of that, and show you what I'll be looking for when I grade your deals, right? So if we do this, what I'm going to first do is go through and say, all right, well, let's start collecting things. First, we're going to always write the null hypothesis, always going to be there. Then we're always going to write the null hypothesis, which we're just trying to figure out whether it's true or false. So in this case, it would be not equal to 50. We're going to identify, well, we can keep recording some things. We can record n equals 30, x bar equals 47, s sub x equals 5.5. As stated in an earlier slide, we do this, right? But then we must identify what type of test we are using. So in this, I'm going to say, hey, we are running a z test, right? And then from there, I'm going to go ahead and record my p-value by going to my calculator just like before, and it's going to come back here, right? Now, we're going to make a p-value statement. You must include this, right? We're going to say, all right, the p-value is less than the significance level because 0.0028 is less than 0.05. Let me take you back a few slides so you can reference this, right? If the p-value is less, then we reject the null hypothesis. At the significance level, there's things to be done here. So the way that looks is this. We start to write, we reject the null hypothesis at the 5% significance level. There is, when we reject, there is evidence to suggest the advertisement is false. All right. All this mathematical is just proving that probably what you're saying there, company, is wrong in terms of your gas mileage. To give you a repeat try, right? A pit crew claims that a pit stop for 4 new tires during an auto race is less than. So the null hypothesis, mu, is less than 13 seconds. The the alternate that you're going to have to write. Is there evidence to support the claim that a claim of the pit crew? So all we want to say is the alternative is if you're not less than 13 seconds, then you're probably greater than 13 seconds, greater than or equal to, right? Because there was a random sample of 32 and the sample mean was 12.9, the standard deviation of this sample was 0.19, and we want to test this thing. We want to draw our bullcrap level, our significance level at 1%, right? Because we had a random sample of 32, we're going to use a z-test. So we go to stat, test, z-test, and we start putting in our information. The naught is 13. The standard deviation is 0.19, 12.9, 32. Now we're going to go greater than, because this is now what's known as when we do this, this is known as a one-sided test. We're not doing equal to. We're doing either greater than or less than. All right. And then I'm going to calculate. I'm going to end up recording my p value as 0.9985. Right. So now I'm going to make a p-value statement. My p-value is actually much greater than my significance level. 0.9985 is greater than 0.01. When we do that, this is where this is this case, right? So now we're going to what's known as fail to reject. Let me write that statement out so you have it, right? We fail to reject the null hypothesis at the 1% significance level. That's not spelled right. Significance level. There is not. It's important when I read through these that your is not matches fail, is matches reject, right? Is not enough evidence to disprove the Pitt-Cruz claim. So essentially what we're saying is we're not, in the statistician very picky point about this, and I see why you guys won't necessarily appreciate it, but we're failing to reject it. We're not saying that the Pitt-Cruz is true. All we're saying is that our sample that we have collected is not mathematical proof to disprove it. We can't lean upon this and say, I got something that says otherwise. All we're saying is with the sample we have chosen, we can't disprove your claim. Carry on. All right. Either way, here's your first problem of homework, right? This is homework number 1. So go ahead and basically mimic this whole process with this one, changing this and these numbers as needed, and this stuff. All right. But all those parts that I've circled, 1, 2, 3, 4, 5, are all going to be graded and all need to be included on your answer. All right. Now let's look at one other one. Okay, now this is an example. In this section, we describe the complete procedure hypothesis test when it's less than 30. All right, if we're less than 30, then basically we're going to use a t-test. So a used car dealer says that the mean price, this is our null, this is what they're claiming, right? That the mean price of their vehicle is $20,500. You suspect the claim is incorrect and find that a random sample is that, and assume that. So all we're doing is assuming that it's incorrect. We're not assuming it's higher or lower. At least it doesn't give us any information to that effect, right? So we're going to do that. Let's record some information then. Random sample n equals 14. That's why we're going to be in a t-test. X bar of this 14 is 19,850. Standard deviation is 10,084. Significance level we're going to use is 0.05 because it's the sample size is less than 30. We're going to use a t-test. So stat test, t-test, stats. Mu sub 0 is 2,500. X bar is 19,850. Standard deviation 1084, n size 14, not equal to. Calculate, and our p-value then is going to be equal to 0.0429. So now when we make our p-value statement, our p-value is less than our significance level because 0.0429 is less than 0.05. So what we're saying is the probability of pulling 14 cars and getting this average, if this were true, the probability of doing that is 4.29%. And that's such a low probability of pulling that sample that mathematically something must be off. And what must be off is our original claim. Since it's below 5%, we reject the null hypothesis at the 5% significance level. There is, so again, I'm going to be looking for reject, and is evidence to suggest that car dealers' price claim is false. Right? Our evidence to suggest that is such a low probability rate. Let's look at that one more time. An industrial claims so that the mean pH level in a nearby river is 6.8. So they're claiming our null is 6.8. You randomly select 19 water samples. The mean came out to be 6.7. The standard deviation came out to be 0.24. Is there enough evidence to reject the company's claim at a 5? So all we want to know is this not the right number? Didn't say whether it's going to be higher or lower, just whether it's not the right number. Okay, because the sample set is lower than 30, we're going to make a t-test. Let's find the p-value. Stat test, t-test, stats. Null is 6.8, x bar is 6.7, s sub x is 0.24, sample size is 19. Calculate. So p-value comes out to be 0.0860, right? So roughly 8%, 8.6% chance of pulling a sample size of 19 with these stats, right? And because the p-value is greater than where we were drawing the line, right? Because 0.0860 is greater than our line in the sand of believability, it's greater than 5%, we fail to reject. So mathematically, we don't have proof to disprove the company's claim. We're saying, okay, you get away with it this time until we pull a better test. We fail to reject the null hypothesis at the 5% significance level. There is not. So again, looking for fail to reject and is not enough evidence to disprove the company's claim. Should probably be something like this if I'm being picky. Company's claim. All right. Okay, to finish up then, this right here will be your homework problem number 2. Again, I'm going to be looking for 1, 2, 3, 4, 5 pieces. All right. So hold all this with you. Press pause on the video. Go back to flowcharts. Go to whatever notes you need to be able to answer these. All right. Okay. Thanks for playing along. I'll see you in the next video.
Daddy, I thought you were going to say bio.
Bye, y'all.